Hi, my name is Sam Sledzieski, and with my co-authors Rohit Singh, Kapil Devkota, Bonnie Berger, and Lenore Cowan, I'm presenting our work on Topsy-Turvy, integrating a global view into sequence-based protein-protein interaction prediction. Topsy-Turvy is also being presented as a proceedings talk by Kapil Devkota in the 3D SIG COSI and has appeared in Bioinformatics this past week. So, typically methods for predicting protein-protein interactions fall into one of two classes. There's local methods, which use protein features and protein sequences to make predictions for a candidate pair. And there are top-down global methods, which use the connectivity patterns of an existing network to predict new edges. Here, we introduce Topsy-Turvy, a framework which combines both local and global approaches for PPI prediction through an integrative training framework. We find that Topsy-Turvy is able to achieve state-of-the-art performance in the cross-species prediction task. So when trained from PPIs on one species and predicting in another species, and that performance persists across multiple subsets of the network. We also show how we can leverage limited network information in a target species to drive predictive accuracy with TT hybrid. So we're going to refer back several times to the table on the bottom left here, figure 1, to track the application case for each of the methods. We previously introduced Descript, which is a deep learning sequence-based method, and thus falls into the bottom-up approach. Descript uses sequences from the training species to train, and then in a new species requires only the protein sequences to make predictions. We also previously introduced Glide, which is a network-based method that uses the network of a target species to make predictions of new edges, and thus falls into the top-down method. Now, both of these methods have their limitations. For instance, Glide cannot be used to make predictions in species where there is no PPI network available. However, Descript misses out on crucial information in the training set by not looking at global connectivity patterns in the way that Glide could. With Topsy-Turvy, we're able to address both of these concerns. Topsy-Turvy uses sequence-based features in the training data, as well as global network information, and then in the target species requires only sequences. The way that Topsy-Turvy is trained is by adding a Glide loss term to the Descript supervision. So Descript originally is supervised using the protein interactions from a ground truth PPI network and generates features based on a protein language model. With Topsy-Turvy, we use Glide to look at the training network and generate scores for all possible edges in the training network. Then we use, when we train Topsy-Turvy, we're supervised with not only the ground truth PPI edges, but the Glide predicted PPI edges. This serves as a form of directed data augmentation, wherein Glide is able to suggest edges that may be absent from the training data as false negatives, or is able to potentially rule out false positive edges in the training data. Thus, Topsy-Turvy is able to integrate both bottom-up and top-down approaches for PPI prediction. In the results in Table 2, we demonstrate that Topsy-Turvy, when trained on human data and then applied in several other species, including mouse, fly, C. elegans, yeast, and E. coli, is able to achieve state-of-the-art performance, significantly outperforming Descript on all of these tasks. Descript has previously been shown to achieve state-of-the-art performance in this cross-species prediction task. We additionally find that the trained Topsy-Turvy model is able to improve on Descript across all segments of the network. So when subset to only high degree or low degree nodes, or edges including those nodes, we achieve high performance, not only on high degree nodes, where performance advantages would be expected for global methods that can look at these global connectivity patterns. Additionally, we performed limited benchmarking against AlphaFold Multimer, but ultimately we were limited by the runtime of AlphaFold Multimer. It takes, on average, about 6 hours per pair, whereas Topsy-Turvy is able to make about 50 to 100 predictions per second. So we've demonstrated that Topsy-Turvy is able to achieve state-of-the-art predictive performance for species where there's no PPI information available when trained on human by integrating this Glide top-down network-based loss term. However, there are many species where there may be some limited protein-protein interaction data, and we want to leverage that information in the way that Glide would. For that, we introduced TT hybrid, which is shown in the center here, figure 3 in table 1. TT hybrid is a weighted combination of the predictions from a trained Topsy-Turvy model, as well as the Glide similarity scores from Glide applied in the target network. The weights here are determined by a cross-validation setup where we calibrate the weight based on a held out human data and a logistic regression. Then we can use these weights to combine the Topsy-Turvy predicted score and the Glide predicted score to make predictions in the target network where there's some data is available. We benchmark TT hybrid by generating subsets of a fly network where we remove some of the edges, use the edges that remain as training data for glide, and use the edges that were removed to test glide, topsy-turvy, and TT hybrid, where topsy-turvy and TT hybrid were trained on human data. We find that across different levels of sparsity, so different levels of already existing protein-protein interaction data, TT hybrid is able to outperform either of its constituent parts. And thus we recommend the use of TT hybrid for prediction of protein-protein interactions in species where some protein interaction data does exist. I'd like to thank my co-authors for this work and thank the funding sources at the NSF and NIH. More information on topsy-turvy is available at the domain at the top of the screen, topsyturvy.ccel.mit.edu. As I mentioned, Kapil will be presenting topsy-turvy at the 3D SIG OC as a proceedings talk, and topsy-turvy is available to download as part of the Descript package. Thank you.